Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to day 37 of NL Math Man's Math Help Streams. These are this is a prime day for numbers, prime time for numbers, right? Prime time, right? Because I'm on in prime time. I'm not. 1 p.m. Newfoundland Standard Time, 11:30 a.m. Eastern Time is not exactly prime time, but we're making do, right? It's prime time for me, is what I'm saying. It's prime time to learn about some numbers and some prime numbers, because of course 37 is a prime number, which we know means can only evenly be divided by itself and 1. Good stuff. It's important. Here behind me today now, I've got, as you can see, I'm well positioned. I'm well positioned for good acoustics here today, right? My voice will carry very nicely across this, amphitheater. This is all these photos that I show in the background I have taken, right? I'm not in very many of them because I tend to be, taking them, right? Because that's kind of what you do when you go on a vacation or something. Like you take the pictures yourself. Now I'm going to be super self-indulgent here, as I am, for my first 5 or 6 minutes every day. But today especially, um, I'm just gonna, I'm gonna talk a little bit about what this picture here is in the background. If anyone wants to hazard a guess at what community this is, I've intentionally not put up one of the more scenic and obvious pictures of this city because it would be obvious, like I just said, you know. But we have a very, very well preserved amphitheater there, which looks very much like the ones out of video games in which these are put in, like the ones you build in the cultural districts in Civ 6. Yes, very important part of the Civ 6 new mechanics, the district placement. Very, very interesting and thought provoking because it makes you plan your cities out in advance. To me, it's really the core. It's one of the core parts of the game. Anyway, yes. Because yesterday I was talking about some of the culinary sort of, I guess, misadventures. Not really misadventures, because that's that's making it sound a lot more than it is. Some of the culinary adventures I've had while traveling, and seeing you can't travel now at all, and seeing this is my stream where I just this is my break for the day. I'm gonna you know spin some yarns about places I've been or to entertain myself. So this picture here, I haven't seen any guesses yet, but this one's, I've mentioned being here before. This is Athens in Greece, right? And when I go anywhere, I tend to look for sort of hiking and food and stuff like that I can go do, right? And when I was in Greece, there was a park called Mounty Mythos right outside, and I decided to take the trail to go up this mountain or whatever it was, right? And before I started, I didn't really realize what the trail was that I was picking. I just sort of picked one that indicated it would eventually get there and just started off onto it. Turns out it was kind of this small little janky trail up just behind a residential area. Like when you're a kid and there's these little trails like in your neighborhood or whatever that to an adult or someone like that it would never look like anything serious whatsoever, but to you and your friends it's like this little place that you go up behind your neighborhood just to like hang out in the woods and I don't know, go eat snacks and I don't know, maybe I'm just saying what I did. But these little places you just go to be away from the adults. Well, that's kind of what it was like. It was just this weird little janky trail that ran up behind a residential area. Right now, it did eventually join up with a much larger park, but it's kind of my fault that I walked on this strange little trail because I didn't do any research. I just sort of looked at a map and hey, hey, there's a place I can go, which is again kind of what I normally do, right? And it ended up sort of on a few foothills. Like this is actually fairly high up here. This is on a foothill in Mounty Mythos. And the problem was, like, I just sort of I thought it was just going to be a little day trot. Like, I don't know. I'm just kind of an idiot, to be honest, right? Like, I think I took one bottle of water and that was it. That was all the supplies I had with me. And this is in Athens, Greece, right? And I had a baseball cap at least, but I mean, sun beating down one small little like 500 ml bottle of water or whatever, right? And out there, it turns out the trail wound and wound and wound and went through like hills and over and through forests, and it was boy oh boy. Um, but eventually, yeah, and I mean, it was rather nice, right? You end up finding stuff like this, like a some. I didn't really find it per se. I mean, obviously there's signs up and it's all it's all demarcated, but it was cool to see some stuff without like a billion other tourists around, which was nice. Yes, good afternoon. Good afternoon, Esther. Yes, I will get back to the math now in a second once I'm done humoring myself with this story. But yeah, the interesting thing about the story for me is that I was out walking around and it ended up being like the day was dragging on. Like I'm talking about like I was there until like it was 4 or 5 o'clock in the afternoon, right? Hadn't had a bite since breakfast. Been on the go all day. Been out walking all day. Didn't have any food with me or anything like that. I was really starting to fade. Like it was and it was a long way to go to get back into the city too. But then it turns out, then I just sort of come down over a hill, and there's a road there, and then I see this little thing. It's the only building I had seen up until that point in the day. Well, aside from this one, there's and a few around this that hardly count as buildings because they were formerly buildings. But this little hut, this little like gazebo thing, I don't know, it's an octagonal hut, and I go inside, and this is lo and behold, this is a restaurant. The first thing I randomly see happened to be this one little restaurant out by itself in this like on this small trail, small road winding through this mountainous park, right? And yeah, I go in, and it's amazing. Like everything is written only in Greek. There's no English to be found, and I don't speak a word of Greek. I can't even attempt to pronounce the words because I don't even know the sounds that the alphabet corresponds to, right? So I'm like a totally helpless child here, and I'm trying to order some food in the restaurant, and the guy behind the counter just does not understand what I'm saying at all. And then I eventually just start pointing to things on the menu, and he still doesn't really understand, like if I want it or not, or if I'm asking about it, I guess. I don't know. And eventually, someone behind me in line takes pity on me who spoke English, and he said, "Oh, okay. I'll just help you for a second. What do you want?" And I'm just like, "I don't care, man. I just want anything. I just want some food. I want food and a beer." And yeah, so I ended up getting this. I just picked the top thing on the menu, and it was this like thick tomato stew of like sausages and vegetables. And I had like a big piece of crusty bread with it, and a nice tall pint of beer. Boy, oh boy, what a like I gotta say, to be walking through a city where I don't know anybody, don't really know the terrain. All I've got is my phone and one little bottle of water that's by now empty, right? And it's a little bit demoralizing to be out and to have no idea where you're gonna go. And the first thing I find is this little random ass restaurant out in the woods, right? With a delicious home cooked Greek cuisine meal and a pint of beer. Boy, oh boy, it was quite the day. Is the moral of the story, and I would do it again. All the all the mistakes that I made that led me to that point, um, yeah, sort of added up into quite a tale, I suppose. Anyway, at this point, I have been rambling about non-math things for quite some time now. Just the topic we were talking about yesterday sort of got me off onto thinking about this. Maybe I'll do some show and tell at some point too. I've got some very nice, like I bought a really nice knife at a market in Athens, and the market like has the view of the Parthenon because like everything has a view of the Parthenon in Athens. Anyway, it's a great time. But that was one of the perks of working in the UK, which I was at the time, right? Is that you can get to Greece without it being like a bank breaking trip. Like if you go to Greece from Newfoundland, my lord, you're talking like what, like a $2,500 plane flight each way, probably. Gladiator? Yes, exactly. Yes, this is actually a set from the movie Gladiator. Right. I did meet Russell Crowe. He's very nice in person, actually. Tell me the square root of pi right now, you phony. Yeah, it's just pi to the power of point 0.5, man. Pi to the power of 1/2. But like square pi, would that be cake? I don't know. Anyway, yeah, I think it's about time to start in with the math instead of the. This is the pre-stream. That's right. That's right. This is my warm up to the cold open, as Todd Glass would say. Okay, so for today, I am going to start in then on set notation and Venn diagrams. So I believe that was That was Calais. Who asked for that? I believe it's pronounced Calais. You can correct me if I'm wrong, but it's got an E with an accent aigu on it, and I do my French grammar memory is enough to know that that should be pronounced A, right? So I guess it will be Calais. I will start off with those ones. Sine and cosine laws review. Betty Ann, I believe there's a few there for you for an activity you had just completed. Determining future value of loans. That one's for Esther. So that one's the one that I've been talking about with you earlier today, I believe. I sent you some notes on that. Then arithmetic with feet and inches. I know that sounds a little bit odd, right? But that was basically just realizing that it's not, you can't use decimals the same, right? It's not powers of 10. There's 12, and that ends up changing things. Us Canadians sometimes have a difficult time adapting to adding feet and inches together if you're not used to it already from carpentry or whatever. But that'll be what I do today. How big brain do you get? Well, my brain's so big it actually isn't in my head, right? I actually had to store my brain in the fridge. Um, I don't get to use it very often. Like right now, I'm operating, like remotely, right? But the brain got so big that I actually, had to take it and put it in a refrigerator in order to preserve it. It's from all the fish that I eat, right? Fish is brain food. Anyway, yeah. So starting off, set notation and Venn diagrams. Let me get that page open over here. Now, Calais, there are some. Oh, my doc cam is off a touch. That happens sometimes. Okay, that'll do. So what I've got here on the right is a page in your book that shows you a lot of the terminology that you're going to need to know for this unit, right? So as we see over here, oh, the cursor's not showing up. There we go again, right? So this one is page, there we go, page 23 in your textbook. So this is a really good resource. You'll probably be flipping back to this one a few times while doing this unit. But here we're talking about set notation, right? So this one, we sometimes read this one as a intersection of A and B, right? I like to refer to this one as A and B, right? So A and B, like we see here, is going to just be, you see this little almond-shaped bit in the middle here? That's just going to be this bit. Because if it's A and B like this, that's just the area that's in both the circles. But if we had the U-looking one, the upside-down one, that's A or B. We usually read that. So that is any element that's either in circle A or in circle B. So that's this whole set, right? And this one here, the slash, we read that as A minus B, like it says, right? So A minus B here, right? A minus B would just be the red bit, not the blue bit, because it would just be sort of this C-shaped bit that's all of A, but not this bit in B. Here, A minus B, well, if they're disjoint, A minus B is just A, right? Because we're subtracting the B bits. Or if it overlaps a little bit, which is probably the most common situation that you're going to see, here A minus B is almost all of A. Just subtract this tiny little bit here, right? And that's just this is page 23 of the textbook. So this is a good page that you'll probably be flipping back to several times as we're going. The question that you specifically asked about, I do want to cover that one. And like I mentioned before, I won't always do questions that you ask me from the assignments because the assignments are for marks. But I am going to do this one, partly because the notation that we're seeing here is something that you might not have seen before, especially where Calais, where you started off on the grade 12 of the math ones. I don't know how recently it was that you did the grade 11, so I'm not sure, if you recall what these symbols here stood for. These are covered before the grade 12 ones, but I'm going to go, so that's why your textbook doesn't go over them specifically. I am going to go over them again here now, though, because, like I said, I'm not 100% sure that you recall. So, this is Math 3101A Unit 1. Oh, and I am zoomed in too far with my doc cam. There we go. That looks a bit better. Math 3101A Unit 1. So, for one, we'll draw a Venn diagram to show these sets. I'll tell you what, tell you what, I'm not going to start off with drawing the Venn diagram. Um, this question I think is sort of written a bit backwards as to what it should be, because honestly, really, you should do part B first, right? Because part B is listing out all of the elements that are in this set. So I'm going to go ahead and do that, right? So the universal set, so set U here is going to be, so I will talk you through what this sort of means, right? The X here before the bar, this one, this just tells us that X is the variable that we are looking for to determine what our set is. Now, that seems like needless, excess for most of these. But when you look at set E, when we get on to doing that one, you will see why it's important to have this bit here, right? But it tells us that X is what we're looking for, and then X is between -10 and +10. So this is what this tells us here. This next part tells us that -10 is less than or equal to X, and X is less than or equal to +10, which, combined tells us that X is between -10 and +10. And then this last bit, what does this mean? X and this weird looking E and then an I, like a thick I. Usually it's with two lines like that. That I is looking thick, right? What this means, XEI, what is that? Well, this is again stuff that you would have seen in previous courses, so I'm going to put that over here sort of as an aside. I is integers, right? So that one you might see. And you might also see this one, the R, and that one is real numbers, right? And then X, E, and sometimes it's written. Sometimes the E is written with a double line in the middle, sort of like a euro symbol. XEI means X is an integer. I'm running out of space here. Right? So that's mostly what you're going to see for that sort of notation. If you have XEI like that, it's going to mean X is an integer. If you had XER, it would mean X is a real number. Now, what's the difference between real numbers and integers? Well, that's something that hopefully you remember from previous courses, because they don't teach it specifically here. But of course, you can just ask and I'll tell you. Integers are whole numbers. So integers are, -1 is an integer, 0 is an integer, 7 is an integer, 12 is an integer. But say, 3.5 is not an integer because it has to be just a whole number. Real numbers are pretty much all the numbers that we think of generally when we think of numbers. There are other sets of numbers that aren't real numbers. There's imaginary numbers. I don't think we get into imaginary numbers in this course. I can't recall off the top of my head if you do. The square root of -1, for example, is an imaginary number, which we call I. But I can't recall if you get into those or not, so I'm not going to load you down with topics that you might or might not ever have to think about. So just basically, integers are whole numbers. And real numbers include decimals. Okay? So now once we go over here, we can start to pick apart, well, what the heck does this sort of notation mean, right? So we're looking for x's. X's are between -10 and +10, and x are integers. So what are the elements? The elements in this set are -10, -9, -8, -7. I think you see where I'm going with this. I'm going to go ahead and write the lot of them out, though. And there we go. And we usually use these curly brackets like that to indicate that it's a set, right? So this is the set notation, but this is the elements in the set, right? So list the elements in each set in the Venn diagram for part B. Well, that's what we're doing here, right? So the universal set is all the integers between -10 and +10 inclusive. We know it's inclusive because it's got the equal to line underneath, right? So now let's do the same thing for the other sets here. So set N is, we're looking for x's. It's -10 less than or equal to x, and x is less than or equal to -1, and then x is integers again, right? So here now, we can see quite clearly that this is going to be a subset up there. because it's mostly the same, just it only takes the negatives, right? It stops at -1. So the number in n, I guess n probably stands for negative, hey, doesn't it? So it's going to be -10 like that, right? It's fairly straightforward. So P is also going to be fairly similar to what we've seen. I am going to keep on working down through all of these ones out because I want to show you E as well. And then we want to check out some of the consequences sort of or the conclusions rather, that we will get to based on what we're doing. Like so. Okay, so then all the elements in set P are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There we go. Right? Because x is integers and x is greater than or equal to 1 and less than or equal to 10. So it's going to be those numbers. Right? And then for E, well, E is a little bit different in how it's written, isn't it? So here, this x bar part is actually important. And why is that important? Well, it's because afterwards in our set notation, we introduce a second variable. And what is that? What's going on here, right? So x is equal to 2a, but then a is the one that we're given the range for. Well, what do we do here? All right, well, what we're actually going to do is we're going to take these values for a, plug them into this little formula, right? And this formula it's not always going to be this simple. The formula could be as complicated as we want it to be, right? It's just this is a formula that we put a into in order to figure out the different values of x. So what we're going to do is we know our values of a are 1, 2, 3, 4, and 5, because it's between 1 and 5 inclusive, and it's integers. So, but then we're going to plug those numbers into 2a, into this formula, to find what the x values are. So for our first value, a is 1. 2 times 1 is, of course, 2. Next value, a is 2. 2 times 2 is 4. And you're going to see that that's the numbers that we're going to get. And of course, if you had to take a wild guess, just a wild stab in the dark, it seems like n is negative, p is positive, and e means even, right? Just taking a guess there. Okay, so now I can go ahead and do a. So I haven't broken out my RGB yet today. So let me go grab some extra pens. What we're going to do is I'm going to do a over here, right? So now I'm going to draw out the Venn diagrams. So in order to draw out Venn diagrams like this, well, we're going to need to do a universal set. I'm going to wait to do the universal set afterwards because it's like, I did some cartooning sort of as a hobby when I was a kid. Like I would draw cartoons instead of paying attention in class or whatever, which is why I'm a teacher, right? So pay attention in class. But one thing you learn, right, is to draw the speech balloon after you write the text to make sure that the speech balloon fits, right? So here I'm going to draw the universal set after I draw the rest of the Venn diagram to make sure it fits, right? Always thinking. Always drinking. Just one of the two. Okay, so we know that, well, we have our universal set. That's going to be the outside one. That's going to be the full block, right? So we don't need to deal with that quite yet. We're going to have our n, the negative numbers, our p, our positive numbers, and e, our even numbers. Now, if we take a look here, we can see that our negatives and our positives don't overlap at all, do they? Right? So I'm going to have my circle for negatives. I'm going to do those in red. So this is going to be n, right? And my circle for positive numbers, I'm going to do that in green. So I'm going to have that over here. This is going to be P, right? So then our negative ones, I'm going to do the full shebang here and just write them all out, right? So in our negative numbers, it's going to be -10, -9, -8, -7, -6, -5, -4, -3, -2, and -1, right? But we see here that our P are these numbers, and E, all the numbers in E, we notice, are also in P, aren't they? 2 is here, 4 in both, 6 in both, 8 in both, 10 in both. So I'm going to do E, and I'm going to do that in blue. And E is in here sort of inside P, right? Because it's going to be, this is a subset, right? So we have 2, 4, 6, 8, and 10 are here inside set E. And then in set P are going to be the rest of these ones, 1, 3, 5, 7, and 9. Okay? Now I'm going to draw my universal set. So let me break out my my math set. Get a straight edge. So the universal set, we generally draw that one as a rectangle, sort of out around our Venn diagrams. Right? And this is how you'll see it done in your book as well. Right? With the Venn diagram, with the Venn diagrams as circles generally, or ovals or oblongs, or whatever. And then our universal set will usually be a rectangle out around them. Now, what's going to go in our universal set? Is there any number that's in our universal set that's not already taken care of for these ones? Is the next thing we had to look at, right? Well, we've gotten all the negative numbers and all the positive numbers, right? So shouldn't that be all the numbers? Well, what about that guy? With that little guy? So 0. 0, in this case, is one of our elements, so that one's going to have to go out in the universal set. Okay, so now we can go on and answer the rest of these ones, right? So list the disjoint sets if there are any. Right? So what are the disjoint sets? Well, disjoint sets are sets that don't have any overlap, right? So we see here N and P. N and P are disjoint. And now, to be totally precise here for these sort of answers, you should also mention that E and N are disjointed as well. Now, from looking at the Venn diagram that we've drawn, you might not think to do that, right? Because you might say, well, I see that E is a subset of P, so obviously if N and P are disjoint, then N and all of P's subsets are also disjoint. That's true. But to be totally accurate and as pedantic as we possibly can be, right? Which we like to be. Mathematicians love to be pedantic. Because technically correct is the best kind of correct, right? Also bureaucrats. Bureaucrats and mathematicians. And outer space potato men. Just going to throw Futurama references at you till somebody on the other side of the internet has some sort of chuckle. That might be a long time. Anyway, N and P are disjoint, N and E are disjoint. Moving on, eventually. Is any set a subset of the other sets? Explain. Well, explain. Explain's a bit weird, but I could say E is a subset of P. Now, I'm okay when they ask you these ones if you just write it out in terms like that. You don't necessarily need to use the symbol. E is a subset of P, like so, right? You can do that, but I'm fine with you just writing it out like in English words, just to show that you understand what's going on here for these ones. If the questions want to test you on the symbols, they will most certainly put the symbols in there for you to read, right? And explain. Well, all you would say is all of the elements of E are also elements of P. I mean, obviously, that's the definition of a set being a subset of another, right? And then E is P naught, or the complement of P, is that equal to N? Explain. Well, what are all the terms that are not in P? Well, we see that P is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So if we were to cover it over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are gone out of the universal set. And then is what's left over equal to set N? And no, it's not, right? It's not because of this 0. And we see that down here, right? So P naught, what we see over here, Oh, let me get my cursor popping up. There we go. P naught, this one here, or the complement of P, is everything in the universal set other than what's in P, right? But here, P naught is not equal to N because there is a zero. Okay, so P naught does not equal N because of zero in the universal set. Okay, so Calais, that is how you would answer that question, the one that you asked me. If you're watching right now, do stick around because I'm going to do a few more on this same topic that are like ones that you will get to in the near future. All right, so I'm going to sort of prepare you to see some of the questions that you're going to get shortly. And let me see, I wanted to do page 32, questions 1 and 3. All right. No, that's not it. Some nice scrolling noises on camera. There we go. As you see here, I'm scrolling through a version of your textbook, the same as the one you've got that I sent you the link to. All right. So here's the ones that I want to cover. Zoom in a little more so we can see it a bit clearer. Yeah, there we go. That's good enough. So I'm going to do questions 1 and 3 off of this page, right? Because this shows you some of the terminology that you're going to be using in your first unit and some questions that are very similar to the ones that you're asked on your assignment. All right, so this is still Math 3101A Unit 1. Right, and this is going to be, what did I just say it was? Page 32 and question 1. Okay. Now, consider the following Venn diagram. So it gives us a Venn diagram up there in the corner. And we had to get, well, see what I mean? What I was just saying about the symbols, right? If they want to test us on the symbols, they're going to show us the symbols and ask us, what the heck they mean. So here now, determine A union B, or this is A or B, right? So what, it's basically A, oh, no, this is question A, although I could have just circled that A, I guess, hey. A, U, B, right? So it's all the elements that are in A or in B, right? So in a sense, right, like the language of this, parsing what the actual language means is, like I keep saying, a really important part of understanding math in general, right? And for here, that might sound like I'm saying and, right? Oh, you mean all the stuff in A and all the stuff in B. Well, kind of, yes. But in this terminology that we're using in this unit, we call this A or B because that's sort of the logic that you use when you think about it, right? You look at one element and you say, is this element in A or is it in B? And if you say yes to that, you're not saying A or B to that. You're saying yes or no, right? So if I look at number 4, say number, 4 here, is that over here, is that in A or in B? Yes, it is. So there you go. That's part of it, right? -8, is that in A or in B? Yes. 9, is that in A or in B? That's right. It is, right? So everything other than what would be outside of it here is going to be in A or B, right? So if we were to list them out, well, it's literally all of them, right? It's all the elements that are there. But I'll just, you know, so it's -10, -8, uh, -6, -4, -2, 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could say A or B is equal to all those guys, right? So it's literally all of them that are in this diagram. So then for B, so when there's an N outside in brackets like that, that means the number of elements that are in that set, right? So number of A or B means the number of elements that are in the set A or B, right? So in this case, number of A or B is going to be what? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. That's it, right? And don't get confused. Sometimes people get confused and think that the actual value of the numbers in the set matter. They don't. Most of the time in this course, our sets will be sets of numbers, but sometimes they're not. Like if you look over here, look at question 4 down here, right? Here it's got the Venn diagram. The information in the Venn diagram is types of vehicles, right? So the info that's in the Venn diagram need not just be numbers, right? So don't get confused. Think that any of this part here is dealing with the actual numbers in the set. This is just the number of elements in the set, right? And then for C, this looks like A and B, right? It looks kind of like an N, but it's not. It's not an N. This is okay. So it reads as A and B. And this is the elements that are both in A and in B, right? So this is just the ones that are in the center. So A and B here is going to be 0, 2, 4, 6, 8, and 10, right? Because A and B, you know what I'm saying, are going to be just these guys here. Okay? And now the number, well, that's fairly straightforward now, isn't it? I'm going to stick this over here so I get a bit more space on my page to keep going. But the number of A and B is, of course, now going to be just the number of elements in here. 1, 2, 3, 4, 5, 6. There we go. Right? So it's not super hard. I wanted to do question 3 as well. So question 3 says, consider the following two sets. A is that, C is that. Determine A or C, number of A or C, A and C, and number of A and C, and then draw a Venn diagram to show these two sets. Okay. Drawing the Venn diagram is one of the main reasons I wanted to do this next one, because you are going to be doing that quite a bit, right, as the course goes on. So then for question 3, 3A, determine A union C. Well, that's all the elements that are either in A or in C, right? So that's going to be, well, all the elements in A, of course, right? And then C appears to, let's see here. So 2, well, 2 is in both. 4 is in both. 6 is in both. 8 is in both. 10 is in both. And then it just adds on 12, 14, and 16. So it's going to be our negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10, 12, 14, 16. There we go. Right? Easy. And the number, oh, we use a curly bracket there, sorry. Number of AUC, or A or C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That was tough. So then we've got A and C. Well, what are the ones that are both in A and in C? And we just sort of went over that, right? So we see that up to, so 2 is in both, right? All these negative ones and the 0 aren't. 4 is in both, 6 is in both, 8 and 10. So this is going to be 2, 4, 6, 8, and 10. Don't mind me. Curly brackets will be okay. It's a little bit misshapen, it's fine. And then number of A and C, clearly just 5. Easy, right? Nothing to it. So then, draw a Venn diagram to show these two sets. All right, so we know that these two do intersect, right? Because there is an A and C component. So I'm going to show them intersecting like this, right? So I'm just going to do this freehand. I'm not going to use a compass or anything like that or a stencil. So here's going to be my set A. That's going to be in blue. Going to be my set C. That one's in red. Right? And here now we're actually not given a universal set, you'll notice. So we're not actually given one to put outside. Normally I would do that after, but this time I'm not going to need to. So what's in generally when we're drawing a diagram, and this is a really important lesson for me to get to here now because there's loads of questions actually later on where this is really important. We start by writing out the ones that are in both. It's always good practice to start by writing out the and ones. So it's going to be 2, 4, 6, 8, and 10. I didn't really leave myself enough space. That's those ones, right? So then, well, what's going to be left over for the C's over here? Well, it's going to be all the elements of C except for 2, 4, 6, 8, and 10. So it's going to be 12, 14, 16 over here in C. And then over here in A, it's going to be all the elements again other than 2, 4, 6, 8, and 10 because we're not going to write down stuff twice, right? And this one is going to be negative 10, negative 8, negative 6, negative 4, negative 2, and 0. There we go. Oh, hey, Slayer Darth. Yeah. That's going pretty well. I'm brushing up on your English. Well, great. It's a good, you mean English literature, English language, English grammar? A lot of different subsets for the English curricula. That's yeah, that is definitely a good one to be working on for sure. And I suppose history too. History is key for studying of English literature for sure. Any literature really. As much as some people might argue otherwise, I don't think anyone could seriously argue otherwise, but you can't really separate, literature from the history in which it was written, right? It always exists in a context. Spent many years on this earth without knowing how to differentiate between independent and dependent clauses. Yes. Lots of people don't. Lots of people don't. The easiest way to do it, dependent clauses cannot stand on their own. Independent clauses can. Like an independent clause is a full sentence if you just by itself. A dependent clause relies on other parts to make it a full sentence. That's the sort of the easiest way of thinking about it. Hence independent and dependent, right? Then you get into like complex sentences and compound sentences and stuff, and it's not really I don't know. It's odd even to have to learn that kind of stuff sometimes because it's like, why do I need to be telling people if this is a compound or a complex sentence? I don't know. But many dependent words such as if or when that determine whether the sentence is dependent or not. Yeah, sure. Yeah, it's a word like that, shows that there needs to be more stuff said afterwards. Because if you said like, when I finish my math, then what, right? Because that word when is there, you need to have another clause in order to finish that sentence because that was a dependent clause. When I finish my math, then what? But anyway, maybe I should do NL Englishman. That'd be good. Oh, that's a bit of an odd name. Because someone saw NL Englishman, they'd be like, "Are you an English person living in the Netherlands?" They're like, maybe it. I mean, even now, people don't. People, your average international audience is not going to think Newfoundland when they hear NL, right? But hey, I slapped it in there. I figure I talk about all-terrain vehicles and partridge berry jam and ginger snaps enough that I've got enough Newfie cred. Anyway, Calais, yes, that was a good look at the beginning of the stuff that you'll need to be doing, right? Um, yeah, you do get on to questions that are a bit more complicated, but I'll let you go on ahead now on your own for a little bit. Let me know if you have any other questions about those. I'll definitely get to some more examples in the future, but I think that's probably a good place for the first sort of lesson on those ones. So let me know if there's any questions about the terminology or how to draw the Venn diagrams or whatever like that, right? But now I'm going to pop back over to my intro screen. Stream starts soon. Nope, it's been going for a while. Um, Sine and cosine law review. Yes, yes. I wanted to do a little bit on reviewing sine and cosine law for Betty Ann. So this is going to be, let's see here. There we go. Then we want to just switch on over to this display for now. Okay, so I'm going to be finding basically everything that I can about this shape down here, right? So this is, I think this is question 1C. So this is math. It's always math. I mean, often math, not literally always. This is math 2101A unit 3 still. And this is going to be, what is this question? This is 2C, 1C. 1C on the assignment. Okay. Sine law and cosine law are, I mean, they're really good topics, and they are topics that are covered in the academic and the general as well, because this is, like I've mentioned before, I believe, this is the final topic of the general program, but it's sort of in the middle of the academic program. Boy, it seems a bit, hold on, just a hot second there, Twitch chat. Let me get my color correction. The brightness might be a bit overdone. Let me ratchet that down a touch. Okay, it was showing up a bit. It seems a little overexposed there for a second. Okay, so we have 114 degrees over here. We have 38 degrees over here, and then we're looking for this side, and we're told this side is 15 meters. Right? Now we can find this side over here. Unfortunately, this is the one that the question is actually asking us to find, is this guy over here. So we have a little bit more work. We have another step first, because we got to find this angle over here if we want to find this guy, right? As long as we're using sine law, rather, right? Because of course our sine law is a over sine A equals b over sine B. We know we can use sine law here because we do have a pair, right? We have a pair of this side and this angle that's opposite it. But we're looking for this side over here. So we have to find this angle that's opposite it first, right? So I'll do this one in blue. So that one is going to be, of course, 180 minus 114 and minus 38, right? We know that because all the angles in a triangle make 180, like I've said probably, 2 or 3 times a stream since I started, right? So, yeah, so 80 minus 14 is going to be 66. 66 minus 38 would be 28. Yes. That one's going to be 28 degrees. Now, of course, don't be too proud to check your mental math. 28. Right? Got to model good behaviors for everybody. So, again, don't be too proud to check. So that is 28 degrees over here. So now we can go ahead and fill in our sine and cosine law for this guy, right? So now we have 15 over sine 38. That is going to equal x, or our unknown side, over sine of 28. right? And then when we're solving, remember we had to get x by itself because that's kind of what solving means, right? Is to get the variable by itself. So I'm going to multiply both sides by sine 28. So I'll write this one out because Betty Ann, I noticed you wrote out this step on your in your activity when you did it. So I'm going to write it out here as well. Sine 28, of course, is just a fancy way of writing a known decimal, right? So these aren't variables. Sine 28 is just a number, right? So, I mean, even if they were variables, we could cancel. But I'm just saying that right now, once we get rid of those over here, we've just got x by itself. And this is all just known numbers that we can calculate, right? So I'm going to go ahead and plug those into my calculator over here, right? So we have 15 sine 28. I'm just going to evaluate that one. I do it in little chunks in my calculator as sort of a way of idiot proofing it because I am an idiot and it needs to be proofed for me. But it's a bit rude of a way to phrase it. But what I mean is, like, if I was to take it and type in sine 28 divide by sine 38 here, if I leave this bracket open, I don't know how the calculator is going to behave. Is it going to take sine of 28 or is it going to take sine of 28 divided by sine 38, which I don't want, right? So in order to be 100% sure that the answers are going to work out like I want, I'm going to put it in bit by bit in the calculator, like so. Or what you could do is you could, you know, close your brackets, like so, right? That'd do it. Divide by sine 38, and then close that bracket. And then you'll see that we do get the same answer. That's going to be 11 point, I'll call that 11.4, just to keep it at one decimal place. So that's the answer that we're looking for there. Say that you did try to find this side over here. I'll call that one y. You know, we would do that the same way as well, right? But it's important to, excuse me, it's important to just work through it correctly, I guess. Obviously, it's important to do things correctly, he says, as a major revelation. Right, just going to quickly work through this. Just to show you what it would be if indeed you did have defined the side that I've marked y. So it's going to be 15 sine 114 divided by sine 38. So that's going to be about 22.3. Okay, so that's just yeah, it's just one quick example of that one that I wanted to go over. Then I also did want to go over question 5 because I showed you question 5 yesterday on stream, but upon checking the answer key, I noticed that I actually did question 5 in a more difficult way than I needed to. Now I tell my students that people do that a lot, and you know this is I'm living proof of someone who makes things more difficult than it needs to be. Let me tell you, that's a common story in my life. It's getting a bit small there, isn't it? I'm gonna in it blood. I'm gonna go on over to this view so we can actually read the question. This is now gonna be question 5. Actually, you know what? I'll do that in green. I'll do it in green so that we can clearly see that it's not the same as the rest of them. I've got some multicolor pens coming from Walmart, hopefully. So hopefully, because this pen is, I mean, I've been using this one for a while. It's not long for the world. But once it's gone, I'm not going to have a green pen anymore. Real tragedy. Crying shame. But hopefully Walmart comes through for me. Okay, so it's supposed to be a parallelogram. So let's, you know, it's roughly Chibudo, right? They say. It's roughly a parallelogram. So I'm going to call this 8.4 cm, and this one over here 8.4 cm. I'm going to call this one 7.2 cm, and this one 7.2 cm. Now we're looking to find the larger of the angles, right? And of course we know that a parallelogram, right, we can draw sort of a line across here through the middle. like so, right? And then the shorter diagonal, as we're told, which is this one here, because the shorter diagonal is going to be, yeah, the longer diagonal would be there, the shorter diagonal would be there. And we're told in the question that that is 10.5 cm. And what we had to determine then after we had drawn this is we had to determine sort of this angle that's here in red, right? We know because this is a parallelogram, we know that opposite angles in a parallelogram are equal. So this one is going to be equal to this one over here. But we also know, and something that we could have used yesterday to solve this one a bit faster, we also know that this angle here, this one that I'm going to do in blue, that one is equal to this one over here, right? Because it's a parallelogram, so opposite angles are equal. So if we find this angle down here, we then immediately can find these ones over here, which is a little bit simpler. What I did yesterday was I found sort of this part, this half, so like this angle, and then I found that angle, and then we added them together. Now that does get you the right answer, but it gets you there with a little bit more work than what you needed to do. Actually, I'm going to do this in black and not in blue, so that it's distinct from the working above. So we are instead going to figure out this black angle, and then the remaining step that we have is going to be actually a little bit simpler, right? But again, because we've got sides and we've got no angle, we have to use cosine law, right? And so we know that that's going to be cos C is equal to a squared plus b squared minus c squared over 2ab, because that's our version of the cosine law that has already been solved for the angles, right? So I'm going to call this guy C down here, right? So if this is C, we know that the side opposite angle C, or side C, is going to be this one, the big one, the 10.5. So we're going to say cos of C is going to equal 8.4 squared plus 7.2 squared minus 10.5 squared over 2 times 8.4 times 7.2, like so. Cos C then, yeah, get that over here. So that is going to be 8.4 squared. What would help if it was on, wouldn't it? I mean, in general, the calculator being on is a useful thing for solving the questions. Minus 10.5 squared is just that. So we have 12.15 on top. Down below, we have 2 times 8.4 times 7.2. So that's 120.96, right? So I'm just going to do 12.15 divided by my most recent answer. So C is going to be the inverse cosine of 0.1004, right? So then C is going to equal the inverse cosine of that answer, which is about 84.2 degrees, right? So we know that this is angle C over here, right? So how about I call this one, how about I call this angle X, the one that we're trying to find, the one in red over here, right? We know now that because this is a parallelogram, well, all four angles in a parallelogram add to be 360, right? And we know that there's 2 that are equal to angle C and 2 that are equal to angle X. So 360 is equal to 2 times 84.2 plus 2 X's, right? So it's this last step that I kind of wanted to do this to show you, because this is a quicker way of doing this one because we don't have to do cosine law twice here now, right? 2 times 84.2 give me 168.4. So 360 minus 168.4 is going to equal 2x. So that's 200 minus 8.4 is going to be 191.6. Yeah. Why don't I just go ahead and write those down and not even check them, right? Because I'm trying to model good behaviors. That's what I'm, right? Yeah, that's absolutely what it is. Divide by 2, it's going to be 95.8 is equal to angle X. And I believe if you check back to yesterday, that is what we got, or at very least, very similar with, a bit of rounding differences between the two different ways that we solved those ones. Right? Need to zoom out a little bit more because I'm not getting the top and the bottom of my sheet. There we go. That's better. That's good. Okay. So, Betty Ann, that was a little bit of a review over some of the stuff that you are working on currently. Right? I don't believe you had any specific questions for me for the next stuff. Um, yeah, if you do, let me know. I can get to them maybe before today's stream ends, but definitely for tomorrow. Just hold on, hold the phone there a second. Running a bit low on paper. I had to go grab some. Okay. So next up, we're going to do determining future value of loans. So now, Esther, this is one that you were working on. And you did get this question correctly. Did get this question correctly? Boy, who pretends to be an English teacher? Not this guy. You did answer this question correctly, but the method you used wasn't necessarily the one that we do in this course. Now, it is a very practical method that you used, and I do show it to students a lot, right? I just want to make sure that that you are aware of the way that the book shows you to do it, which is a bit overlong, to be honest. But and then also I wanted to talk you through sort of why the method that you did works, right? And then show you kind of the formula that you were using, which is what we call the future value formula, is normally what we call it. Zoom out so we can see the full thing. So, Anne just bought a new truck. Base price is $50,500. Right? What a nice way to light $50,000 on fire, buying a brand new vehicle. Maybe he says ruefully, driving his used Hyundai Accent. So Anne just bought a new truck. The base price is $50,500. She added some features that cost $1,500, and she also has to pay for freight and PDI charges, which cost $1,800. All prices are before tax. What is the total cost of the car? Okay. Math 3102B. This is unit 1. Right? So it's going to be question 2. I'll do 2A just to walk through it, really. But I mean, this is not a difficult question, is it? All I've got to do is add those numbers together and then add tax, right? And we're going to use 13% for tax for whatever reason. 0 cases again, 14 days straight. Yes, yeah, it's great. It is great to see, isn't it? And yeah, a lot of provinces in Canada are doing a lot better. You know, even say in Nova Scotia, it's getting a lot fewer cases, and they're trending downwards there as well, which is really good. Let's hope numbers start to drop in Ontario and Quebec too. That'd be, although they are dropping. The number of new cases in those provinces is lower than it was previously, at least from what I've seen. So that's quite nice too. So that's just the total pre-tax cost. Now, of course, to get tax, we're just going to multiply by 1.13 because we're using 13% tax in this course for whatever reason. Right? Because I mean, 15% is correct because that's what it is currently, but whatever. 13% tax, $60,794 dues. Which is not dollary dues because those are Australian dollars. This is Monopoly money, which is Canadian dollars. Okay, so now for 2B, that's the one that I wanted to get on to talk about. If the truck depreciates at a rate of 20% per year, what will be the value of the truck in 5 years? Now, the way the book shows you how to do it is honestly a bit foolish. Like I said, it's a little bit overlong, but I'm gonna talk you through this one. So this is the book method over here, right? So right, if it depreciates by 20%, then we have 100 minus 20 or 80% remaining after each year, right? So literally all they do to get year 1, say, you know, is just going to be to take the original value. Well, I was just about to write down this number, but we don't. We don't actually use that number, right? The answer key The answer key just uses the 50,500 as the value of the truck. Now that's fine. If you did that on a test, I would mark it right because I'm not, this is not a course about like personal finance or something. You don't actually need to know what the value of the truck would be. The value of the truck would actually be 52,000, right? And that's what I'm going to use here because the $1,500 worth of features that does increase the value of the truck, of course, right? Whereas the freight and PDI charges, those don't increase the value of the truck, and taxes also don't increase the value, right? If taxes increase the value, then say like a vehicle bought in Alberta would be worth less than a vehicle bought in Newfoundland because Alberta has less tax, right? But of course, we know the opposite is true. A vehicle bought in Alberta is worth more because Alberta is an inland climate with, you know, much drier and doesn't have the constant salt blasting that Newfoundland gets that rusts our vehicles out within a few years, right? It's one thing about Newfoundland. Like if you drive around here for a while, you might, if you're from someplace else, you'd be forgiven for thinking that everybody just has a lot of money to throw away on new vehicles, right? But mostly it's because like you just hard to drive a vehicle for more than 5 years in Newfoundland before it literally starts falling apart, right? Because of the amount of salt on the roads and in the air and just in the boy. Remember that I don't think any of you guys were here, any of the current students when I had the G5, but the previous vehicle I had before my current one was a an old Pontiac G5, and the rocker panels like on the bottom of it that runs parallel to the doors, right, like down below, they literally rusted like clean through. Like you could break off pieces with your fingers, like right through the metal. It was like driving around on a piece of Swiss cheese. It was. Remember when I had to change tires one time because I got a flat, and I looked at it and like I tried to put the jack on it to jack it up, and it just started crumbling, and I was like, this is not good. This wouldn't pass inspection like this one, let me tell you. And then when I traded that vehicle in, they ended up giving me less on the trade than they had anticipated, but they still gave me something, right? That was at Jerry's in Gander. They still gave me $100,000 on trade for that vehicle. So it's pretty good in my mind. But your textbook, to get back to this question that I've been rambling about, all they do is multiply each time, which is nonsense, right? But this is how the book shows you to do it, right? So we take the 41,600 times that by 0.8 again, because there's going to be 80% of it left, and then they just keep doing it times zero point 0.8 gross, right? Like, how much extra work is this? Do it again. I'll do it again. It's like that meme with Goofy, right? The red meme with this like poorly drawn picture of Goofy. I'll do it again. So that's going to be I should realistically be putting dollar signs in front of all of these, and then 5 years. Do that one again. It's going to be now. This is Esther. This is going to be a little bit different than what you had because, like I said, um, oftentimes students don't include the options as part of the value, but technically it is. So I'm going to be technically correct in my answers, but I would not mark somebody wrong for leaving that part out. Right now, this is the way your book shows you how to do these questions, and like I said, you see what I mean now. Probably this is a bit overlong. Like, why the heck do all these steps when you don't need to, right? So I'm going to show you here now the formula method. One reason I was a little bit leery about you using this method is just because it brings in exponents, which is definitely not a difficult math concept by any stretch of the imagination, but we haven't really talked about it very much in the program. But the exponents that you use are totally a good way of doing it because, well, this is just zero point 0.8 to the power of 5, right? Indeed, it is. But say we know that the future value of a loan is going to be the previous value multiplied by 1 um, plus the rate to the power of well, it's actually rate over n to the power of n times t. This is the full formula. And if we were to go on and do, say, if you did the economics course that we offer as an elective, which I mean you're not going to do because you've already got your elective sorted. But if you were to do that, this is the formula that you would see for a loan like this, where FV is equal to the future value, PV is equal to the previous value, R is equal to the yearly interest rate, N is the number of compounds year, and T is the time in years. Now, this might look a little more complicated than what you did to figure out the formula method, but this is really the formula that you were using. And I'll show you why now in a second, because we're going to start filling stuff in, and you're going to see how this matches up with what you did, right? So your future value, well, your future value is what we've got to figure out, right? We don't know that. So I'm going to have future value here for our purposes. Here that equals x, because we don't know what the future value. Boy, that got dark all of a sudden, didn't it? This camera, I got to tell you, it leaves something to be desired. So the previous value, well, the previous value is, let's see, 52,000, because again, I'm going to use the pedantically correct one. Yearly interest rate, well, the interest rate here, it's not really an interest rate, right? Because it's not growing, but we can still think of it the same way. We can still think of the interest rate. Here it's going to be a negative 0.20, like that, right? Because it's decreasing. Hold on a second. I need to re-up my my brightness. There we go. So, number of compounding periods per year. Well, here for our purposes, we don't really need to figure this one out because n equals 1, right? Because like I said, this only happens yearly. Number of compounding periods per year is really important in some personal finance settings, right? Because if we're talking about, say, oh my God, hiccups again. Hold on, just 1 second. Okay. Boy, when you're talking for, apparently when you talk for like an hour and a half straight, you end up giving yourself hiccups. Who knew? Streamers probably. Um, yeah, so the number of compounding periods per year here is just going to be 1. Lots of times, like we'll talk about loans that are compounded monthly. Sometimes they'll be like predatory loans, like like payday loans that'll be calculated daily, even or weekly or so, right? But we don't need to concern ourselves with that. For this one, it's just going to be once a year, and then T is your time in years. So that's the power up in the corner, right? So your future value, what we want to find out. Actually, forget that. X is going to equal previous value 52,000, right? Times 1 plus negative 0.20. I know I just put 2 brackets next to each other, which looks awful, but bear with me here. I'll show you why. Because it's a plus in our formula because it's to do with investments, right? Investments grow. But this is depreciation. We're losing money actually every year because that's how vehicles work. You lose money year over year. So it's going to be a negative. So we're going to have x is equal to 52,000 times 1 minus 0.20 to the power of 5, or x equals 52,000 times 0.8 to the power of 5. So then we are going to get the answer, because the power of here, what a power like that means is it's 5 0.8s times together. It's not 0.8 times 5, but it's 5 of that number. Just like what we did over here, right? We times it by 0.8 once, twice, thrice, twice, and sice. Those last two I just made up. Yeah, but we multiplied 5 of them together. So here, that's what the 5 in the corner means. There's 5 of these 0.8s. So 52,000 is 0.8 to the 5. Here we go. 17039.36. And again, right, Esther, that is a little bit more than what you had as your answer because I'm using 52 instead of 55. 50, 52. 52,000 instead of 50,500. Yeah, so that is yes, that was what I wanted to cover for your one today, Esther. So yeah, hope that explained a bit about why that question works the way that you sort of did it out with that formula you used. So now to bounce back over to my intro for one last time here. Yes, arithmetic with feet and inches. Right, and that has nothing to do. I'm not going to be counting things on my toes here, so don't worry. You're not going to see my gnarled and twisted feet on your stream. Although I think that's the kind of stuff that doesn't happen on Twitch. I'm pretty sure that kind of thing happens on OnlyFans. Anyway, so arithmetic with feet and inches is going to be some stuff for Renetta off the most recent thing that she did. So let me just bring that up and then bounce back over to it. Yes. So again, this one is a bit of an oddity that we had to deal with in sort of Canadian mathematics. Um, Although you see it sometimes come up in when I was in the UK, you would see it come up occasionally. But Canada and UK are both similar in the sense that we are very weird about. We never quite made up our minds if we use the metric system or not, right? UK is the same way. Like, you know, uh, most of the time it's centimeters, right? Centimeters and other sort of metric units. But then you go on the highway and the speeds are in miles per hour, and it's like, wait, what? Why is the speed in miles per hour? I thought this was like metric land. And then, but then you go to measure your weight, and it's measured in stone, and it's like, well, stone is just like 14 pounds, right? So it's kind of imperial, but even like a more obscure version of imperial. Anyway, my car gets 4 rods to the hogshead, and that's how I likes it. So saith Abe Simpson. Right. So this is now Math 1102A Unit 2, I think. Yes. Thank you. Send the review sheet shortly. All right, sounds great. I will maybe get to that today. I can't guarantee that I will get to that today. I have quite a bit of correcting backed up. Well, actually, not that much anymore. It's mostly just this unit of physics for Troy. So I'm going to tuck into that there now in a bit. I was leaving that one because I don't have an answer key for it. It's a bit of an undertaking to get through it, but I gotta do it eventually. Got to make that answer key. So maybe I'll even go through some of those activities on stream tomorrow. We'll see. Physics is a great subject, but it doesn't have as much. I don't have as many resources to support the physics courses as I do for the math courses. But yeah, I do quite like those courses in general. So anyway, so here we're just going to do 4 foot 9 inches plus 2 foot 7 inches. Sign up for test for Tuesday? Yes, great, thanks. Do send me an email for that though, and then I'll add you on the list. So when we add feet and inches like this, kind of what we're doing is we're just adding together 2 separate numbers, right? Because there's 2 problems that students frequently make, and Renetta, I believe you made both of them. So, but just nothing to you for this, right? I mean, it happens very frequently because it's just a little bit unintuitive how different it is than the decimal math we're used to doing. Right? But when we add these two, we kind of had to treat them as 2 separate columns. We can add feet with feet, and we can add inches with inches, but we're not going to mix and match, right? So we're going to call this now 6 feet, 16 inches, right? But now what we have to do is this 16 inches. Well, how many feet is that? And that's not 1 foot 6 inches. It's not. I mean, it looks like it is to someone who's used to dealing with metric. We might say, hey, there's a 1 and a 6, so that's 1 foot 6 inches. Boom, sorted, right? No, it ain't. What that actually is 1 foot 4 inches, right? Because a foot is 12 inches. So 16 inches, of course, equals 1 foot 4 inches. $12 per foot, right? We can think of it. You can think of it like 16 over 12, right? 16 over 12 as a fraction. If we reduce this down, we would have 4 over 3, right? But actually, no, let's not reduce it down. Let's not reduce it down. That equals then 1 and 4 over 12, right? Which is 1 foot 4 inches. Let's not worry about the reducing it down. That's actually defeating my point a little bit. This is one of those cases where we're going to leave our fraction intentionally, not reducing it down to simplest form, right? That equals 6 foot 16 inches, which is just, I said 7 foot 4 inches. Easy, right? It's easy once you know to look for that. And then 17b, do that one here in blue to differentiate. That one is 5 foot 10 inches times 2, right? And there's a lot of easy ways to make mistakes in a question like this. But what we're going to do, again, we had to treat them as if they're sort of two separate. Like this is like 5x and 10y. We can treat it as first, right? If it was 5x and 10y, we know after we multiply that we're just multiplying both terms by 2. So we would have 10x and 20y. So here it's going to be the same sort of deal. 10 inches, 10 feet, 20 inches. And then if we had, our 20 over 12, right, 20 over 12, we know that's going to equal 1 and 8 over 12. So that's the same as 11 feet and 8 inches. Right? So that's all we had to do for those ones. It might be a little bit unintuitive on the surface, but, it's not too bad, especially when, people often are used to operating with feet and inches in Canada just because, all our measuring tapes come from the States, so they generally have, even if they have metric on them, they tend to also have imperial. I'm just going to also do 18 here as well. Now, let me go back over to this display so we can see it a bit. I believe I've done this question on stream before, and that's just a testament to how unintuitive a question like this is for students sometimes, right? But for question 18 here now, what we have is find the length plus girth of the cylinder if the radius is 4.8 meters. So it's for 4 marks on this activity. 4 marks just for this one. But we have to remember that girth, which is not a term that comes up very often in math, right? We don't talk about girthy math all that often. But all that is the distance around the end of the shape. So for a cylinder, girth is the circumference of the circular end. Right? That's all we got to do. This is circumference around the circular end. We know that circumference is equal to pi times d, right? So then circumference here is going to equal pi times, they give us the radius of 4.8. If r equals 4.8, diameter is equal to 2 times 4.8. So diameter is equal to 9.6. So it's going to be pi times 9.6. So circumference then is going to be 9.6 pi's. And I'm going to use, again, I'm not about that 3.14 life. I'm going to use the pi button in my calculator. 30.16, I'll call that. 30.16 centimeters. Now, it's not centimeters squared. It's not centimeters cubed. It's just plain old centimeters because girth is a distance, a length. Right? And then the length, here, we were given that, equals 11.3. Now, I think sometimes when people see this, they overthink it a little bit. The question is asking you for length plus girth, and guess what? That's exactly what they're looking for, just that. Just take length and then add girth to it, and you're done, right? So length plus girth is just going to equal 11.3 plus 30.16, which is then going to give us, I'm going to throw significant figures to the wind and go ahead and add that, even though as you would see in later science courses, you actually are not supposed to. The 6 would actually kind of disappear here because of significant figures, but we'll ignore that, right? And it's going to be 41.46. There you go. Easy. That's all there is to that one. Excuse me. Okay. Hey, look at that. We're right about on time. Right at my hour and a half. Okay, good. I do have other teacherly duties I have to, to get back to today. As it is, as you do, right? Let me just pop back over to my intro screen here. Yeah. So I had a nice discussion about that hike that I took, where I ended up at this very lovely restaurant that I don't know the name of. If anybody, I tell you what, if anyone in chat knows the name of this random like gazebo shaped restaurant in Mounty Midhouse Park in Athens, Greece, you could that's yeah, that'd be an interesting thing to find out. It was a lovely meal and very well appreciated after that, you know, day of hiking in sweltering sun with just a single water bottle to keep me company because I'm an idiot, right? And then no real map or, well, I have my phone, but no real knowledge of where I was going. But sometimes you just keep going. You just keep and the adventure sort of works itself out, I guess. Right? Just like the math, right? You just keep going and it works itself out. Hey, that's what I'm talking about, right? Anyway, thanks for being here with me for another day. I hope the stream has been entertaining, interesting, compelling, and helpful, or at very least one of those. Right? Stay safe, and yeah, hope to see you again tomorrow.